Hope everyone's Friday is going very well today. And this meeting will be recorded, so
Yeah,
we'll
I
make
just
sure that
had the
everything is
recording
sent out.
thing for.
Fantastic. All right, and Bryant is here. So we'll just wait for a couple more minutes. Dr. Bandy, how are you? Ami,
Doing
good
good.
to see
How
you.
are you doing?
Yeah,
Yes.
good to see you, Anish. I've been keeping you busy with ideas.
There we go. Always great. Always
I
great. It's
left
been a
another
busy week.
seminar to be here with you guys.
Oh, thank you so much, Patrick. We're going to make it worth your while, I promise. It's going to be a really great hour. We have a lot to talk about. It's a really pertinent conversation because everybody's talking about artificial intelligence, but nobody's talking about the father of AI in space. We hear so many conversations of the grandfathers of machine learning and such. Who was the person way before Sam Altman, way before Jan LeCun, way before Gary Marcus? It's only one person, and he's here today. Bryant, I think we should just start.
You're making me blush, Ayush. But as far as I know, I was the first person to apply artificial intelligence into spacecraft operations.
Nice. Congrats.
And that was a long time ago. You know, today with the of course the hype and the societal it's become a societal fascination right now, the LLMs and chatbots and ChatGPT. A lot of people um, don't remember or don't know that there was a different kind of AI that was out here before that came along. And a lot of people don't realize that there's another kind of AI that will be here when LLMs are gone, and that's us too. But in the old days, it was something called, I say the old days, it was called symbolic AI, and it was expert systems. And it might be interesting to know how I came to get involved in space and AI at the same time. But I was interesting enough, it's been brought to my memory lately. When I was 5 years old, my father took me to a movie called Forbidden Planet. And on that thing was this crazy cool spaceship. And they went to the planet Altair 4 and discovered, hidden wonders. And they had this marvelous robot called Robbie the Robot, which was just what you think an AI should be. Truly, as Dr. Bandy says, here is a robot that has the comprehension to understand what you're telling it to do and the intelligence to go off and do it. That was my idea of AI, and it's still my idea of AI. And I've never deviated that. But it also got me, fascinated by space. So years later, I, um, after about a decade flying airplanes for the Navy, I wanted to get in higher up than I could get into C-130. I went back to graduate school at Hopkins and got a degree in space systems engineering. And it wasn't too long before I found myself working on the Hubble Space Telescope mission operations contract. And that was where we were getting ready. The vehicle hadn't been launched yet, but getting ready to fly it. And we had out at Goddard Space Flight Center, we had this beautiful, fancy showpiece control center. We had about 7 or 8 consoles, where each console was dedicated to operating a different one of the major subsystems on board. So we had a data management system console, a propulsion system, optical telescope assembly thing. So I'm walking, I get settled in there. My job was to train the data management system engineers. And I'm looking at the way they're getting ready to fly this thing. It was the first time we really got into a major spacecraft operations center. And the way they were going to get ready to fly it was to they had computer consoles, just like computer, control centers do today, but on these things were these tables of telemetry values with a mnemonic and a value, like a mnemonic like CBAT 6 VLTS, and then 28.2, 28.3. And we had to understand that that mnemonic meant battery 6 voltage, and that was engineering converted. So these are coming down as the digital numbers from the spacecraft. And you might have 100, 200 of these things. It's 4,000 parameters. You had all these different pages you're leafing through to find a number you need when you need it. And I'm thinking, I tried to imagine what it would be like to fly an aircraft, looking at tables of numbers, you know, torque and voltage and things that you'd be dead. And I kind of just right there got a mission. I said, spacecraft are being operated like science projects. We need to start operating like vehicles, like we operate aircraft to be much safer and sure. And I came to learn that spacecraft were lost because people sent the wrong hexadecimal command, or because they couldn't recognize the state of the vehicle because they couldn't keep up with the patterns of changing telemetry values. And the system was the computers weren't doing anything for you except converting individual binary telemetry values into engineering units like voltage. So back then, as I said, like today, AI was a big deal, but it was a different kind of AI. It was called expert systems, and it was based on the idea that you could write a rule, you could bunch a bunch of rules of individual statements, which would like be data. So you could do like if battery voltage is greater than 20.2, that's like one assertion or one query. And then if it's above this, and so voltage is here and the pressure is there, you could if, and then you could do a there, then, and you could specify another bit of information that had to come out of your head. You could say that the state of the battery was reconditioning or discharge or whatever was appropriate to those patterns of values. Now, that was not exactly my idea, what I thought AI should be. In fact, it was a long way from it. But I was trying to solve a real problem. I've always been interested, of course, in going back to undergraduate school, intensely interested in knowledge and how we know what we know and the relationship of our ideas to reality. But in this case, I was trying to solve a real problem. I wanted to make this operation of the spacecraft safer and more reliable. So the game in town was expert systems. So I said, I'll give that a try because it looks like that we simply to do that. I think I could learn how to use a tool like that, what they call an expert system shell, and write these rules. And I have the knowledge. So I could take my knowledge and I could put it into these rules. And they call these knowledge-based systems. In retrospect, they weren't knowledge. It wasn't knowledge. It was still manipulating information and data, but it would still look doable. So I launched off on a program to do it. I got Lockheed to send me their toolkit, their expert system shell. And I got NASA to give me permission to put the shell onto one of the ground system computers. And I wrote the first application. I think the flyer for this was the first real-time application, but the first one wasn't real-time. It was actually, we took a computer dump from the onboard computer of the onboard memory and did an analysis of a portion of that memory where the computer would store its various error flags. So I wrote the rules and say, what do these mean? And come back and give me the state of the computer. And it was a lot of work, It took me 6 months of midnight oil, logging into the NASA computers from home, but I got it working. It was pretty impressive because it would have taken, it go through, it still was slow. It took 20 minutes to crank through all those rules, but it still would do an analysis that it would have taken me as the analyst, 2-3 hours. So I thought, look, this is a real value here. If we can get the answer to what's wrong with the onboard computer in 20 minutes instead of 3 hours, I could save the mission. And, I took it to NASA and they thought, that's great. And they patted me on the back. And next thing I knew, they sent me off to Lockheed AI Center. It's interesting, just like now, all the big tech companies were all invested in AI. But in those days, it was the big tech companies were the aerospace companies, and it was expert systems. But I got to go through a 6-month residency in artificial intelligence, as it was today. And it was equivalent to a master's. Most of the courses, there were 3 months of courses and then 3 months of practicum. And the courses were mostly given to us by the Stanford faculty. This was in Palo Alto. The Stanford was just down the road. So it was pretty much equivalent to a master's in AI from Stanford. But then we had a 3 months practicum. So here is where it got interesting. The problem is that the speed of these expert system shells was not sufficient to keep up. It was very computer intensive. Of course, computers weren't like they are today. They were a lot slower. We were using microcomputers called a VAX in those days, 32-bit architecture. But they weren't fast enough to keep up with a real-time stream of telemetry. So I became the mover of a program out there at Lockheed to build a real-time expert system thing that would have enough performance. And it got to be interesting because we had to put it on 3 different computers to get enough performance. We had to put the telemetry interface on one computer and the inference engine, which processed the rules and did the reasoning, on another computer. And then we had to have the displays, the user interface, which gave us nice graphical cockpit-like displays that had been dreaming about, on another computer. But the catch was, this was like 1989, and there wasn't any software that could transfer data from one computer to another. So the team had to write their own. And later on, as it turns out, when the expert system, that symbolic AI approach, didn't really prove to be scalable for something as big as spacecraft operations, or for most things really, the company went on to take those data buses that they had done, and they became a middleware company. And to this day, a lot of the financial data that flies around the internet flies on the descendant of that data bus. And a neat thing I learned from that is, if you try to solve a real problem rather than have some theory about AI, but really want to solve a real problem, even if you miss the thing you were aiming for, you might solve another problem, which we did. But anyway, go a little further, and that so expert systems didn't scale. Why not? Too many rules. And it's basically still at the data level. Each rule was like one assertion. And the difference between data and information and knowledge. I mean, data is like a simple assertion, like battery's voltage greater than 28.2, or the sky is blue, or the number 49, or your zip code. That's data. Information is when you organize those like organize symbols in a sentence in English, or binary numbers in a spacecraft telemetry stream, or information in a database. That's organized information. But knowledge is something different. Knowledge has a very unique internal structure, which allows it to function as an internal model of the external world. So I wasn't ready to give up spacecraft operations. I hadn't solved the problem yet. So my next company, we were still struggling with rules, and we had this great insight. And that was, one day we were looking at, well, what's the knowledge look like that we're trying to get into the computer? And so we were sketching out, how the spacecraft engineer, in this case, we were looking at a launch vehicle, a real launch vehicle, the Conestoga. We were trying to build a control system for it, a launch control system for it. And we said, well, what did it start? Well, we have a system at the top. We call it the Conestoga Launch Vehicle, and it has subsystems, propulsion, guidance, ordnance, what have you. And then they each have subsystems, and all the way down to the component level, where you actually have telemetry values, where you're measuring, like a battery under electrical power system, measuring battery voltage. And what you were trying to find out while looking at the telemetry numbers is, what's the state of the component, and how does that state of that component affect the state of the higher level systems, all the way up to the top. Like in a launch, in a launch countdown, you're trying to find out that the state you're looking for is ready to launch. Go, everything is right. Everything's where it should be. You want to look at every single telemetry point. But of course, with the old-fashioned way of looking at things at numbers on screens, it's hard to do that, because humans are very bad at it. And as the stress of the countdown, I used to joke that as the countdown goes down, so does the average IQ of the people sitting on the console. They get harder and harder to figure out what to do. But we're looking at this spacecraft launch vehicle functional schematic as a state machine. And one of our programmers said, that reminds me of an object-oriented design for an object-oriented software program. And it was like, wow, what if we wrote a markup language that would allow the space systems engineer to describe the vehicle as a state model of systems with subsystems and states. Just write it down in this markup language. You don't have to know any programming at all. You don't have to get out of your space engineer's head and start thinking about chaining rules together or anything. And then we wrote a parser that came along, and we parsed that specification, that state specification, that model. So it was a model, truly a model of the spacecraft made out of information. Took that information model, and we compile it into a software object structure that could run on a machine. And we built a launch control system It ran on PCs when typically you have to run them on mainframes, and we did them for a tenth of the cost of a northern thing, a normal satellite control or launch control system. And we did it for a tenth of the price. And we had 10 times the automation that anybody had ever seen before. It was amazing. It was like turning on a light in a dark room. And that launch control system was revolutionary. It was the most highly automated one ever built. On the first launch attempt, our system stopped the countdown, showed everybody what's wrong. None of the humans, the people looking at it, saw what was coming. Our system saw it, stopped the countdown. Next launch attempt, stopped the countdown, but then came back and said, "Look what I'm showing you. It's in proper state. It can only be a failed sensor." Everybody agreed. They launched on time, and so that was, I believe, in some ways, you could say that's really the first time AI was really applied to spacecraft operations, because the expert systems, but from my current perspective, aren't really AI, because we understand intelligence to be, at New Sapience, is knowledge in a machine. And if there's no knowledge, you don't have intelligence. And by the way, there is nothing inside of an LLM that could remotely be considered knowledge of anything. It is just probability patterns of word sequences. There's no knowledge in there. There's no ideas. There's no concepts. Nothing like that. So by that definition, expert systems weren't AI, and LLMs are not AI. But what we did back in the mid-90s, that was real AI. And it wasn't just hype, and it wasn't just aspirational. It didn't kind of work. It didn't work, just kind of work most of the time. It didn't kind of work sometimes. It worked perfectly. No hallucinations, no telemetry value missed, no incorrect conclusions. It worked. And so it took a while, and the Altair's technology didn't end up revolutionizing space operations after all, although we solved the problem. That was what I was going for. Knowledge in the machine, and set it up to operate spacecraft just like we operate aircraft. But some things happened. And what happened was that the commercial space was, all the investment in commercial space went away because of the failure of Globalstar and Iridium. And there was no commercial space for quite a while, for probably 7 or 8 to 10 years before it started to revive. So I went on to do other things, but I had cashed out of my first 2 companies. They both ended up being successful and being acquired, and gave me some time and a little resources. And I said, can we take what we did at Altair and apply it, that not just to spacecraft, but to the common sense world? And in fact, can we use the same kind of approach to model any kind of idea? Technical, common sense. Can you model abstract ideas? Can you model concepts which are concepts of how we feel, as well as how we think? Can you model perceptions as opposed to sensations? And that was a long road, because we had to go right outside of computer science, and it probably took 10 years. The first 10 years, we're working with a chief software architect doing prototypes before we kind of uncovered the hidden structure of knowledge, which allowed us to create these very, very compact data structures that we can take any or all knowledge eventually and put them into these compact, scalable structures with minimal resources. I mean, we're getting the same, just like compared to any other technology, we can do it for a fraction of the cost and a fraction of the time and get multiple orders of magnitude more capability and automation and intelligence, true intelligence. So that's how space led me into AI. I don't know if I call myself the father of AI. I'm certainly old enough, I suppose, in space. But we have the thing to go back there now. Now it's time to go back to space. Now there is commercial space again, and we have exactly what the industry needs. because they need to go. Now it's not a joke. NASA didn't have to go to airline operations. NASA didn't have to have all that automation technology. And they were kind of the only game in town commercial space right up because they like that big control center with 100 people in it. And that's they don't want to really reduce their head count. So they don't really want automation. But if you look at commercial space ops today and they're talking about we're going to launch all these things like airline ops, they need the automation. They need to be able to, you need to be able to launch your launch vehicle and say, you know, launch vehicle, are you ready to launch? And it comes back and says, yes, all systems are nominal, we're good for launch. And we can do that with our technology. We can build HAL 9000, if anybody's old enough to remember HAL 9000. Some of you are. I'm sorry, Ayush. I'm done now.
No problem. Just for everybody, we're going to be opening up the Q&A, so please feel free to throw your questions in. We'll be up until the top of the hour to answer as many questions as we can. But just while we're writing, Brian, I have a quick question for you. When will our value, being New Sapiens' value, be recognized by the broader artificial intelligence community?
Well, there are probably people in the broader intelligence community that would rather die than acknowledge what we have. But the answer is, I think, fairly soon. And we're working on our business plan to focus on our first commercial products. In fact, we may be able to bring that forward by focusing on more narrow applications that based on. We have the idea of our consumer product being the companion Sapience, which has a lot of capabilities, kind of can function as your auxiliary memory and so many different things. But we can narrow that down a little bit. Suppose you just needed an app that knew where things were, and you could go through and you could open every door in your house and say, well, in this drawer we have, and you catalog all the things. Or you're moving and you're packing boxes and saying, I'm putting the blender in box 57 along with the red tea towels and all that stuff. And, be able to come back a year later and say, where's the red tea towels? I mean, I would love that today. And I think that would have a huge commercial application. And we might get to a product like that within months, assuming that we can keep our cash flow coming in and keeping the team going and growing. So it's going to be, it's really a matter of, I think will happen pretty soon. But when these things come out, they're going to be able to do things with natural language that the LLMs can't touch. It's going to be a fundamentally different product, a fundamentally different experience from using. And by the way, some of you had asked questions about, do Sapiens have a limit on prompts, or how big can the input be and other things. You're not thinking about this right. Never say we prompt a Sapiens. What you do to a Sapiens is you talk to it, just like you talk to a human being. And the process it goes through is exactly the way that human beings go through their understanding of language. They analyze the grammar, they look at the semantic meaning of the words, they go back into their model, their own ideas, and see if they have ideas that correspond to the words you're saying. You look at the grammar, you put those ideas together. That's talking. That's not prompting. Now, I'm glad they don't say that about LLMs, because that's not talking. What it is, it's designing a prompt, which is to seed it with a bunch of word patterns that are going to cause it to be able to find other word patterns that can come out and give you a big output that may or may not be useful, or may not correspond to reality. And if you don't correspond to reality, you say it was making things up, but that's silly because it makes everything up. Sometimes sometimes the statistical average, what everybody says, is useful.
So it's voice command.
It's not a command. It's a conversation.
Well, yeah, well, okay. Oh, so so in other words, you're just talking to it like we're talking right now.
But it is talking, because talking is decoding language. Language is a message.
Mm-hmm.
The way it works is that there's syntax and semantics, and you relate it to pre-existing ideas in your mind. So the Sapiens has what you would only have to call a mind, because it's furnished with knowledge and ideas and concepts, which are all interrelated and very carefully put together. And so you can say whatever you want to it, or you can give it a book to read.
Yeah, but the problem is we've never seen it, and you know what it does, but we don't. So that's why we're asking these simple.
Oh yes, I don't mean to be critical of the person.
Oh, okay.
What we're doing with the prompt.
So I'm just clarifying that. So you just get it and you talk to Helen like I'm talking to you.
Exactly the same.
Okay, that's what we need to know.
It's exactly the same. Yeah, that's the point. So
Okay.
yes.
Okay,
And
perfect.
there's no limit, and yet you could say, well, we have a mode, they have a story for you, and you can just cut and paste a story and text and drop it into the to the input thing, and sit there and read your little story
Right.
in the same way. So uh, I'm a stickler about these terms.
Yeah, I understand because you're the technical expert.
Well,
But
no, not, but people, and this is a lot of confusion. We had a question, good question, by the way, how talking about LM reasoning models and all the things that they are saying they're doing, but it makes my I won't say hackles rise, but they're egregiously anthropomorphic in the terms they're using. If you look at what's really going on, that's not chunkifying inputs is not reasoning. It has a
right,
vague
right,
correspondence to the way humans reason, but it's not reasoning. Reasoning is logic and appeal to um, causality and reasoning. Most of the reasoning that we do about the world is you take this idea, you take that idea, and you see if they fit together to make sense rather than nonsense. And that's what sapiens do.
right.
That's reasoning. Okay. But what LMs do is not reasoning. So they keep coming up with these different techniques. And some of them get better results in terms of now, well, the results are also questionable or problematical. What they usually talk about are how well they do on made up tests that are made up for LLMs, or they'll test them on tests that were made up for humans, but those are always question and answer type tests. And LLMs are good at playing the question and answer game, have been since IBM's Watson, wasn't maybe even an LLM, but anyway, that beat Ken Jennings at Jeopardy, and then come up with, to me, whether ludicrous claims that because it beats got 100% in the law board test, that it was more superhuman intelligence. There's nothing going on in there like intelligence. It was able to answer the questions by matching this pattern to that pattern, but never knew what it is that the question meant or that the answer meant. So it's a fundamentally different thing. So whatever they say, and do we compete with them? That was another question. Or where are we in the competitive analysis? We don't really, except in the area that eventually, when we do curate lots of knowledge and put it into Sapiens, for instance, we envision a project, a fairly large project, but not a large project in terms of money compared to the money that pours into LLMs, which is billions of dollars. But we could take an entire encyclopedia and very carefully, using our toolkit, we could curate all that knowledge. In fact, we could take the 10 best encyclopedias and put them all together and curate all that knowledge and put it into a Sapiens. And at that point, we will be directly competitive in the process of as a question answer about general knowledge. That's one of the use cases people use things today. Now, our earlier Sapiens won't compete with that because we won't have curated that knowledge. Although even before that, we probably will give them enough reading comprehension that to go out and look up the thing and read the encyclopedia article, which still gives you way better reports than you'll ever get from ChatGPT or any kind of chatbot. So it's a fundamental different technology. We're not doing the same things. We're not doing the same things. Really, the only thing that's common right now is the term AI. And frankly, it's not a very good use. Again, if there's no knowledge, you shouldn't call it intelligence.
But we promote SI.
Yes.
And that's where we have to make the separation, and that's what I mean,
That's
you
what we do.
you obviously have to talk about AI, but at New Sapiens, we're talking SI. At least when I'm working with Anish and Aaron as far as promotion and product expansion on the back end. And see, we can't until you proved Bloom's taxonomy at level 3 in the last session. There's not a lot we could do because you can't promote until you have a product.
We understand that,
Yeah.
and it's even it's in terms of promoting us and in terms of for the investors, it's always been a challenge because investors go through a very logical process typically. I mean, and I'm talking whether you're what's called a retail, investor or personal or professional angel or whatever. Go through a process called due diligence. And if you're talking technology, you first will look at the pitch. You look at the technology, maybe look at the demo, and you say, well, that's intriguing, and in case of it's plausible. Here's our explanation of we give enough to try how it works. If you got the attention span for it. That's one problem right up front because it takes some time to get your head around what we're doing and get your head around how different it is. And the more you know about LLMs and that, kind of the more you have to unlearn before you can kind of clear your brain out and start putting these new ideas together in a new way and start talking about epistemology and internal structure of knowledge and atoms of thought. That's completely alien to that. So first of all, you've got to have patience. And let me thank all of you for being here today and for your patience. And with an open mind and be willing to learn about something new. So thank you. But you need that attention span. So first, that's the first thing. But then suppose you go there and you say, okay, that's plausible. I heard what they had to say. I get it. It's plausible. So the next thing you do, your next step in due diligence would be you go out and ask an industry expert who's outside the company and say, what do you think of these guys over here and what they're doing in AI? And where do you go to find that if you're evaluating new Sapience?
Don't you just go to your customers?
Well, if we had customers.
Well,
we
I mean,
we don't have customers.
we don't have them
customers,
now.
it'll be easy, and we're getting closer to have customers. And I think
because we have to have a product.
Yeah, well, we have a technology yet. Okay, we have a platform. Okay, now we have a platform today that could do very competent things in market verticals. For instance, if we wanted to going back to my last company today at New Sapiens and go out and talk to somebody building a rocket and say, do you need a control system, a launch control system? Because we could start building that today. The platform is there. And for an application like that, you're always going to have to put proprietary knowledge. So there's going to be a period of knowledge acquisition whereby we're learning about the rocket and putting that into the model, into the Sapiens, into its model on top of the general world model. But now we have expert knowledge about a particular launch vehicle that's been added to that general world model. So that's going to take a period of time, but we're ready to do that now. It's just a matter of having the bandwidth of doing the marketing and maybe show what we've done in the past. Typically, to go to a new field like that, you kind of have to do a pilot demonstration on your own time and your own dollars. And we need the time and the resources to do that. We don't have enough people on staff. We just added 10 new people and we just got them trained. So we're about to get some new things. But so we're ready to do that now. When we do something like that, it's going to attract a lot of attention. But meanwhile, when we get our first other applications on the consumer side, like the Where Is app or the Remind Me app, the Smart Reminder app, or another one that we're looking at advance of the Sapiens would be to be able to talk to a person who was ill to talk about their symptoms. So all those things are not that far away, and they're going to be revolutionary, have a revolutionary impact.
I was
Fantastic.
just thinking.
I'm just going to interrupt Tommy just so we can get to a bunch more questions because we do have lots more queued up.
Oh, okay, sorry.
No problem. For Brian, what is our confidence level that we can overcome outside entities like big tech that will not want us to get to this general artificial intelligence? We've heard so much about GPT-5, Claude 4 was released, Grok 4 was released. It seems like more and more hype is built around AGI. We actually have it. So how are we going to deal with this outside external entities?
I mean, what are we going to do? What is our plan for big tech or
Absolutely.
big AI? Well, we have a strategy for that. We sometimes refer to it as the dancing with elephants strategy. It's multiple leveled. One, of course, is we're and a lot of people don't know this because it's just happening. We had for a long time, we've had a core patent, but now we're working with a company called AIPI, which are themselves a patent firm, but also an engineering team. They are analyzing our technology right now. I'm going out to meet with them on Tyson's Corner. They're going through all our training stuff. They're building a whole patent fence for us that is multiple patent disclosures and they've already spent about 3-4 months analyzing what's already out there. And they found no patents out there that would likely be able to infringe or be claimed in, as prior art to what we have or what they're going to add to it. So first of all is to have a very good patent fence. So they have to either license from you, or if they wanted to get in this game, either license your patents or license your technology. What our intent is to license our technology. We will sign an agreement with Apple. You may have heard Apple's having a little problem with LLMs in terms of their Apple Intelligence. We would be quite happy to help Tim Cook out with Sapiens to make Siri truly intelligent. And so all of a sudden Siri is a Sapiens. They may not advertise the fact, but maybe there's a little logo called, Sapiens inside on all these applications. But first of all, yes, we will license our technology to them. Will they buy it from us? They'll have to. It'll be so superior in terms of, compared to a chatbot. Maybe not all at once, because chatbots do have a use in document preparation. And for a while, they'll still have an edge in general knowledge. The beautiful questions that Sapiens can ask that an LLM can't ask is something that you told it about you. Okay, LLMs aren't going to be able to remember stuff for you that way. But later, it'll be able to get any information. People have suggested, well, can't you work with LLMs in kind of a synergy way where LLMs could come and a Sapiens could evaluate its output, and to say whether it's, likely to be true or false? Probably not, because in order to do that, it would have to have the knowledge, the actual knowledge to compare the output with, like a human being would have to have to validate whether it was a good or bad answer. It will someday, and I think that will happen quicker than people think, because it seems like a lot of knowledge and a lot of processing when I talk about encyclopedia, or for that matter, I talk about everything that's in the Library of Congress, or I talk about all the knowledge that was accumulated by mankind and written down in books, encoded in books since the beginning of civilization. But if you look at how long that would take us to curate all that information and convert it into knowledge in a Sapiens, it's still not much compared to the money pouring into LLMs. Which is just crazy when you think of, the problem with LLMs is that I think people will find, and they're starting to find out, that even the ones who like using them, whether they use them for things and say, hey, this is great, they seem real accurate, it's probably less accurate than people think. Because when you look at a study where people take experts and say, only ask the chatbot questions that you can say, is it a right answer? Is it a partially right answer? Is it a partially wrong answer? Is it a totally wrong answer? Or is it no answer? So they did some studies when they got experts who could answer those questions. And you know what they found out? And they looked at all the chatbots. They were wrong more than they were right, according to the experts. And you don't know that if you're using it as a question answerer, because if you knew the answer, why are you asking the chatbot? And if you want to be sure, you're going to have to go and research it. So if you're going to use a chatbot to answer questions that you're going to have to go research if they're true or not, you could research it in the first place. So again, why are you asking the chatbot? So the use case as question answer is really very narrow. There is one. And that use case is, let's say I want to evaluate the assisted care living stuff. So if I think in my mind, what it would be helpful if I knew what most people in the local area said about the various assisted living things. And it would come out, not what they think necessarily, but what they said. Not even really that, because what people say doesn't always match what they mean to say. But even so, averaging up what people said doesn't always coalesce into a real meaning, but it always sounds good. But that's still useful because it can point you in the right direction. So as a research tool to save you some time, I think they have a legitimate use case. But don't trust them for anything where the answer is actually something that really matters. That could be dangerous. As you probably know, even recently, even just 2 weeks ago, somebody asked, I think it was ChatGPT, to suggest a good cleaning formula from some bins they had to clean out. And gave him a nice little recipe. It sounded great, warm water with soap and vinegar, and put in some, I won't say what it said to put in because that, because the recipe was a recipe that would have caused deadly chlorine gas. And this was something they asked a which is based on ChatGPT 4, by the way, which was supposed to be much better with hallucinations than ChatGPT 3. Well, it isn't. And ChatGPT 5 won't either, because it's inherent. It'll always sound better and more convincing. It'll always be slicker, always be more slicker fun. I guess they build these bigger and bigger models and program them to flatter you and to engage with you, but the hallucinations aren't going to go away.
Ray, please. You have your hand up.
Yes, I've got one question and one comment. The question is, how well is your IP protected now? And do you have good plans to keep it protected as you move forward? And the comment is, I haven't used ChatGPT hardly at all, but I use Copilot regularly. And I guess I'll call them conversations. I'm typing and they're typing back, but on subjects that I know very well. And if I ask a question, a leading question, they'll come back with the most common thing you would find on the internet, but not the right answer. And then if I tell it what the right answer is, it can come back and with references that show that I'm right.
Well, do you check the references that they are real? Because they did a study recently on citations. When you ask the chatbots to come out with a citation for a reference about this answer, and they were wrong. I mean, they were made up like 90% of the time. So you have to go back. If you actually follow the link and get to the real citation and take the time to say, this was a real study, on a real website by a real organization, then you go. And look, I'm not saying they're not time saving. I'm just saying they're problematical. Because an answer that always sounds right, but it can't guarantee to be right because the process that created that text is not necessarily related to knowledge and logic and reasoning. It's just not. And it looks
the research I've done to learn what I know about the subject, I look at a variety of sources and I think they're reasonable. And when ChatGPT comes back, they often will have some of the same things that I've learned from.
I agree. They're often right, often useful, and often right. I'm not saying that they don't have a valid use case.
But then the question is
that they're not as
what I have taught them, will they be able to use that going forward if somebody else asks the same question?
They don't learn from you. They don't learn anything from what you say. They only learn from what was in their training data set. You're not educating, and people can't educate. It's not an education. It's not a process of education because there's no comprehension there. They don't understand what the words mean that you're telling them. They have no ideas to relate those words to. So it's just everything you say to them is a prompt. So which is going to generate an output. And sometimes, the output is something you can take off and use. But for whatever use they are, and again, I'll make a prediction that there's going to be a lot more disillusionment about these things down the road as people use them more and more. And the other thing is they're not getting that much better because they're already in the flat part of the curve in terms of the scalability problem. I don't know how much people are aware of it, but the very core nature of LLMs is such that if you add a bigger data set with more data parameters, that every data parameter has to be connected to every other data parameter. So the processing, the training the model is an exponential curve, and it's exponential in the wrong way. It takes progressively more and more processing.
So what percentage of the LLM energy use in terms of nuclear power plants or whatever is your software going to require to do similar things?
It's immeasurably small. Ayush, I think you had statistics on that. I mean, ChatGPT said that it costs $700,000 a day just to run. Our Sapiens runs on an iPhone, and you're paying the bill. The energy is so small, it's not even measurable. And we don't train them. They don't have to be trained. We go through the process of putting the knowledge in using our tools. So you have a synthetic intelligence engineer, taking some man hours to create that knowledge. That takes some energy. But we're talking about staffs of people, tens and twenties, maybe 100 would be huge. It's minuscule. It's just not a factor.
Thank you.
The next question comes from Sabrina Burns, which is, what is your advice to people who want to increase their economic value in a workforce that will be increasingly reliant on artificial intelligence? And Brian, what are the top skills they should be focused on developing?
The way Sapiens, the very nature of what they are, is they are machines, they are computers that can process not just data or other information, but they can process knowledge. Most jobs that are information type jobs, as opposed to physical labor or creating art, is knowledge intensive. So Sapiens are going to come alongside you with knowledge, okay? And they're going to be initially there to augment you. If you want to know how to get along with Sapiens, learn your field, study your field and become expert in it. And then when Sapiens are available to help you, they'll be like a colleague that has a perfect memory. But it's more than just memory, and the signs of to survive in the world alongside of Sapiens, you'll have to have a good world model and one that they will help you furnish. They're going to be your aides and your helpers. So clarity of thought. One of the things about using an LLM to generate your documents is you're not going to be a better writer from that unless you're already a terrible writer and you give them a document and they make one that's better than you could have done. But that's not going to make you a better writer. It might make you have a better product. Although realize that LLMs are statistical averages of what people said, so they're never going to get above mediocre or average, level of eloquence in terms of the writing style and skills. But at any rate, the Sapiens the impact they will have on society, and we give this deep thought, is they're going to be artificial intellects. And we are designing them as tools for humans to use. And not only individual humans, but in organizations and companies to use to enhance their productivity and those kinds of things. But they don't require any different given skills. If you want to work with a Sapiens, your best skill is to be able to speak and articulate well. And you'll do better if you have your own expertise and you have a well-ordered mind and can think and speak. And that's what you need because they're just augmentations of human intellects. They're not aliens. There's no special skill required to talk to them or interface with them. So it's really a matter of what do you want to do in your career or your job, and how will that relate to Sapiens? But let me go a little bit beyond that. So let's say Sapiens are there and they're artificial intellects, and are they going to take jobs away from information workers? Yeah, I think they will. Not all at once. Initially, they will be helpful and they will augment. But the first jobs they take away, the ones that humans don't like, the ones that are boring, as well as the tedious, not to mention ones that are dirty and dangerous when you put Sapiens into robots. And they can do a lot of different things. And what do you want a Sapiens to do? Suppose you had a robot that could do almost anything you ask. I mean, here's where the humanity comes into it, and the effect of human society comes into it. If you have a Sapiens and it had a robot that could do almost anything you asked, make you anything you wanted, what do you want to do? What do you not want it to do for you? I mean, that's where the interesting question is. I know I don't want the Sapiens to take vacation for me. I also don't want a Sapiens to write a document for me. I love writing. Okay, I want to do it, and I think I'm good at it. And even if I had a Sapiens that was good at it, why am I writing in the first place? Because I'm communicating my individual unique thoughts that the Sapiens doesn't know, except to the extent that I've told it. But in any case, that's what I do. So the question of how do I prepare for AI in the sense of as coming from Sapiens and not coming from this rather interesting, but in some ways bizarre technology called LLMs, is just how do you prepare for your life for the career and the job that you want to do? You often do that. But with the understanding that you might have a powerful helper at the time when the time is right. But do what you want to do. Programming is the same thing. Will a Sapien someday, LLMs are also helpful in programming, same kind of caveats about programming. I don't think they're going to take everybody's programming job away. But some people who love the program, I think, will continue to program. And they use Sapiens to do the boring parts of programmings. But the true creativity and the creative urge that humans have, that's not going to go away. Sapiens are there to help humans be human. Did I answer the question?
Yes, thank you.
As one of the last questions, just before we wrap up at the top of the hour, from Sal, thank you for being here, Sal. Who gets to decide what a sapiens will learn, and how will it know if what it learns is correct?
Good question. Before I get that, I don't want to forget, I know Ben Bain's been asking about a voice interface on Sapiens. Guess what? They already have one. It's just not turned on on the iPhone right now, but we use the voice interface that the iPhone uses. So you can speak to your Sapiens just like you're talking to Siri, and it can talk back to you just like Siri's talking back to you. In fact, it uses the same voice. In fact, you can set the iPhone up to give it whatever voice iPhones have. If you want to sound different than Siri, you can set that up. So that's already there. That's not something we need to do. Here's another one I don't want to lose. Can Sapiens be biased? But the question was, going back to the other question, who decides? Well, if you talk, there's lots of different kinds of knowledge. All knowledge is in one sense has common underlying structures, and is a model of the external world. But some of those models don't fit reality as well as other models, right? So if I have an elaborate model of something, let's say, of a previous civilization that I could dig up in the desert Mesopotamia, I might have a lot of knowledge about that, but it turns out you dig and there was no thing there. So it turned out to be wrong. But there's a lot of knowledge out there that is the most useful and certified and knowledge that we have, which is applied science. The atomic theory of matter is a theory. It's a model. All models are theories. All theories are models. And we don't even say of models that they're true or false, but we say that they're useful and they produce the results we want. So for Sapiens, the knowledge that we put in there, the highest figure of merit is knowledge that will produce good results if you apply it and use it in the decision-making process. Well, that is an objective study. We have recognized authorities. We have recognized methodologies. We have trusted sources. That's an objective science, and that's what we do at New Sapiens. We'll be going through and getting the best minds and going for the best sources. And the stuff we're building today is common knowledge, and common knowledge is by definition what everybody agrees about, except for, there's always a few like flat earthers, but that's not a problem. That'll just be modeled as there's these people over here who think the earth is flat, but common knowledge is that it's a sphere. So there's not a problem with this. And Sapiens will be trusted and relied on because they come from trusted, relied on sources. That's an objective thing. And they'll produce good results. However, there's a lot of knowledge that isn't just necessarily about practical decision making. There's fiction. There are imaginary words. There are crazy theories that people have. All that's knowledge, a kind of knowledge too. But as we categorize and annotate the knowledge, we'll say, well, this over here falls into the kind of models of the world, which are in the category of spiritual beliefs. And that has a role. And this is what people think and say and feel about this. And so that will be curated along with everything else. And so it's not that we're going to do just this knowledge. It's going to be ultimately the capability of doing all knowledge. When I said everything that's in the Library of Congress, how many of those books in there are necessarily about objective reality? It's still part of human culture. All of it will go in, but the sapiens will have the discernment at the higher level, at Bloom's taxonomy level 6, to say, well, this kind of information and knowledge has this. And then there's a lot of things that just don't coalesce into a definitive answer. So, for instance, if you ask your sapiens, what toothpaste should I use? And it's mature and down the road and has a lot of knowledge, it would say, well, something like 9 out of 10 dentists recommend Crest, if that turns to be, the facts that are, out there for it. So it's really not an issue here. It's not my opinion about the world. It's what everybody thinks about the world, but all carefully annotated and curated and put in the right buckets to give the best possible outcomes. And even back in the days of expert systems, people said, why would I trust the expert system? I'd say you would trust the expert system for the same reason you trust any expert, because asking it questions and using it and relying on it to help you gives you good results. And so we're very confident about Sapiens in the same way. But by the way, it can hallucinate, cannot, because it doesn't have mental fits, but it can only give you the best answer based on what your question you're asking for when it's retrieving information. Now, the question about bias. This is an interesting thing. We hear a lot about bias in LLMs. Well, of course there's bias in LLMs, because LLMs are a statistical summation of what everybody says about any given talk, and people are biased. And if more people are writing that have this bias, and people are writing in the same data that have that bias, then the LLM is going to be skewed to the average, which is what most people do, and will be the bias, which is a common bias. And how are you going to fight that with an LLM? You can't, unless you curate every single thing in the data set, which would be a Herculean task. And then you would be the case of only putting in stuff that you think is objective. And then whose opinion is that? Same kind of stuff. If it's, Sam Altman's opinion, he's going to do the bias that way. So there's always going to be bias. You can't get rid of it. In LLMs, on Sapiens, on the other hand, they're inherently resistant to bias. What do I mean? Why? Because we categorize, and as I say, and curate every concept on multiple dimensions. And some thoughts or concepts are inherently reflect personal, subjective feelings, or as opposed to objective observations or objective information or knowledge. Again, if you've seen a demo, if I say owl is a big, beautiful bird, and I come back and say, what's an owl? And it'll say it's a big bird. You think it's beautiful because it knows that beauty is a subjective experience that a human being has. If I say something that reflects a negative opinion, that is words that have those connotations, it's going to recognize that that's my opinion. Even if I say to my sapiens today, ChatGPT is a mindless stochastic algorithm, and it'll say fine, and come back to what's ChatGPT. It'll say it's a stochastic algorithm. You think it's mindless because the word mindless reflects bias. Now, if I gave it a scientific discussion as to what I meant by a mind and why, objectively that would not be probably to attribute to a LLM, that would be a different conversation. So it's not, you can spout off all you want to your sapiens, but it's not going to, it's going to understand that you had this subjective opinion and that's your bias.
Fantastic. Well,
yeah.
Please, Bryant, finish because we're right at the top of the hour. We want to just take 1 or 2 minutes to leave people with the state of the company.
Yes. Um, Again, that gets back into categorizing, scientific something that was derived through the scientific method and has been tested in applications in which the entire, world community relies on, and it's not arguable. It's different. It's very easy to categorize that objectively as opposed to, things that people are angry about or upset about or enthusiastic about, and that or whether it reflects certain theories from certain segments. That's an objective study. It's not arbitrary opinion. You can tell the difference between arbitrary and biased things. They can go in the model. Okay.
Well, everyone, this was a very fun hour. Bryant, I do want to take just a couple of minutes since we're past 4 to talk about where we're at with New Sapiens right now and what we'd like from the community, what we're doing right now, the state of Sapiens, etc. So if we can just leave people with just 1 or 2 minutes of information of where we're at right now and potentially where we're going.
Okay, I'll discuss some things, and if I'm going to be looking in the future again, let me give you the standard disclosure. Predicting the future. I mean, prediction is hard, particularly about the future. And so, if I look forward, looking about stuff and all that, but I'm pretty excited about where the company is right now. We're raising money from people like you, and over the past 10 years, we've raised over $8 million. And we've raised about half of that with 2 crowdfunding campaigns. We have one open right now. We also have a Regulation D campaign for accredited investors, which is kind of a better deal share price wise, but we're looking for a bigger number in terms of the investment. But anybody can invest in New Sapiens right now. And, as I mentioned, the company we've been working on this for 20 years. Um, and But we're maybe 6 months to a year, assuming the cash flow is there, of our first products, which I think is going to blow the doors off the world in terms of the AI community and the public perception. So this is a very exciting time. And we think that when that thing happens, we think that is going to obviously do amazing things to our share value and our share price. So if you're coming in on a crowdfunding thing now, $6, what's it going to happen when the world recognizes that we've solved AGI? So the next thing we might do is, the next money we raise or the next valuation, we may go from $100 billion valuation to $10 billion valuations. That would even be a big number in the AI world today for a startup, particularly once we actually get to a product. I mean, Ilya Suresker's Safe AI company has a $37 billion valuation. They don't have a product. They don't have any product. They don't have revenues. It's just perception. Perception is everything. So this is a great time to invest, and we need the cash flow to keep us going and to expand our staff. We invested a lot in training over the last year, and we got a trained staff that are moving the Sapiens forward faster than ever. But there's another possibility. I'm going to mention it, but don't quote me on it. But there's a possibility that there's a new changing to the rules such that there's something that on the correct platform can have what's called a secondary market. And what that means is our shareholders, once we stop raising money, we said we're going to close our crowdfunding or we're going to close our CF or Regulation D, that our existing shareholders can go to the secondary market, and and other people who might want to come in to buy shares in New Sapiens and say, well, we're not raising money, they can go to our existing shareholders. And if any of them want to make them an offer on their shares. And for some of the people who are coming in earlier, that's a great deal. But if our share price goes up like a rocket in a year or 6 months, any one of you would be able, at the price you invest in now, would be able to get liquidity on your investment, which is a new thing. And it's pretty cool because it used to be that you could only get liquidity. That is, you can sell your shares if the company was acquired by a bigger company, or if We had what's called or we got went public. And, it's really not appropriate. We don't typically go to public because you want to access that huge private, the public as a source of capital and equity, because you got to raise billions and billions and billions of dollars. We don't need to raise billions and billions and billions of dollars. Again, it's so compact. We just need, we might need a whole university of experts, but that's still not billions and billions of dollars. And so we will be raising more money, I think, and we can raise bigger money to accelerate. But this is a way that there'll always be a way that if you need to get your money out and the stock is going up, you can do that. I think that's real attractive. And I'm not promising that's going to happen because we're still talking to the platform, and I'm not even going to name who they are. But I think it's going to happen. Sincerely, I believe it probably will happen. In any case, there's also the option that because of the business model and the business plan, this company stands to be able to generate huge profits. Because again, we don't have to have giant data centers. We don't have to raise billions of dollars and build nuclear power plants to power those giant data centers. And we don't have to hire PhD algorithm designers who are getting $100 million hiring bonuses. We don't need that kind of money. And our thing runs on the user's computer. So our profit margins, suppose there's 5 billion mobile devices out there now. And if every significant portion of those 5 billion people, I mean, we're talking about the number of penetration of that market a la Facebook. And if they're all giving us $5 a month for their Sapiens on a subscription basis, we'll be able to return huge profits to our investors. So that would be a company like the old days. People invest in the company not because they're gamblers speculating that the share price is going to go up, because they're getting very good return on a monthly basis in terms of dividends. I'd love to see that happen. One real quick question I saw pop up: Why do we going crowdfunding and individual investor angels? Because of what it's been called the 0 to 1 problems. Because institutional investors have become like lemmings that all chase the same thing at the same time. And right now it's LLMs, and they're all chasing LLMs, and they don't go and do their own due diligence anymore. It used to be institutional investors would go out and they would research. They would look for unusual companies with an unusual approach. They don't do that. They haven't done that. That started changing 10 years ago. It wasn't the case when I did my first company, which was venture funded 30 years ago. The venture capitalists were really interested in something that was new. But crowdfunding and institutional investors, I'm not individual investors. We're starting to talk more and more, though, as I think the cracks are beginning to show in the LLM. A lot of people are starting to realize the emperor has no clothes up there in terms of LLMs. They do have their use cases, but they're not going to create infinite productivity anytime soon. That opens the door to us talking to institutional investors. And I think we will. Right now, we are very focused on raising $5 million through individuals and through crowdfunding, and that will get us where we need to go. That will get us to profitability. And after that, I think very, very rapid expansion with a rapid increase in our share value. Again, that's forward-looking statements, but I sincerely believe it's true.
I do want to thank everybody for staying with us for all this time. Please visit investnow.newsapiens.com for more information of our Reg CF. Feel free to visit newsapiens.com for more information about our website. You can find new documents like Synthetic Intelligence 101 and the company readily available for download. If your question didn't get answered today, feel free to email com@newsapiens.com. But Bryant, thank you so much for being here, for talking with us all, and everybody. Have a great weekend. Can't wait to see you again.
Thank you.
Thank you.